Hi, we've now come to lecture 7, which concerns upper level vector analysis, as we have been told earlier. And this is 925 hectopascal streamline analysis for Africa and Europe. So we'll begin with North Africa and Europe, and later consider West and North Africa. This is the map of Africa and Europe, the streamline analyzed map of Africa and Europe for 925 hectopascal level on the 27th of February 2013 at 1200 GMT. As usual, this map is of low resolution, so we have cropped it. So I will begin first from North Africa and Europe, having it enhanced. And this is the enhanced map of Africa, North Africa and Europe. Remember, this is streamline analysis. As I said earlier, streamline is a line drawn tangential or parallel to the instantaneous wind velocity. These wind values are instantaneous wind because these are winds taken at a particular instant in time, and that's 12 GMT all over all the stations. So these are lines drawn parallel or tangential to the instantaneous wind velocity. So we are no longer concerned with values of geopotential height. We are now concerned with the direction and drawing lines parallel to the direction. So looking at this top north right hand corner, we see wind there. Of course, the magnitude is given, but we're not concerned with the magnitude. We just look at the direction, and then we draw line parallel. And then over here we see that the wind here is going towards northeast from southwest. So we must turn this way and put the arrow there. And since the turning is anti-clockwise, and that is the case for a cyclone, we have a C here, cyclone. Likewise, the next line we are drawing, we draw it also parallel to this and parallel to that. So we take it like that and then curve it this way. The next one is this one. We draw it parallel and then turn it around there. And the next one again, we draw parallel to this station and that station, and then over here, as we get closer here, the thing is turning from northwest to about from northwest to south from northwest to southeast. The thing is now a southwesterly wind here. I mean southwesterly wind here, but here it was a northwesterly wind, and it turns and joins this. And this is what we know as the asymptote of convergence. Right? The next one, we take it again and draw a parallel to all that, turn around, and then to this direction, and put the arrow there. The next one is here. We draw it parallel and continue over here. We turn around parallel, and then here we draw parallel. We continue looking around to ensure the lines are parallel to the wind direction at that particular station, and then it follows this and curves this way. But at this juncture over here, we see that there are other winds south of it that are from around northeast, and therefore this has to branch out in respect of this wind for this station and go down like that. We branch out parallel to this and continues, and this wind is turning this way. We respect it and follow the direction, and also here we continue until we get there, and this is arrow put there. So this branching we see here is now the asymptote of divergence. This is diverging, coming out from this mainstream line. This another one again here, coming out and turning like that. So we continue, another one turning out like that, and then to this point, and the arrow is put there. Right? So the next one is from here. As it gets to this point, it diverges, asymptote of divergence. Some following this direction, another one this way because of this wind here, and the one then passes through the center. So this now turns like that because of this wind, and this one then because this wind is again from southeast. It turns to from southeast, going towards northwest, and then again, the wind is turning around again. We follow it, respect it, and do that. And then there's another wind here, so this thing now become an anti-clockwise flow, leading to what we have here, C, that is cyclone. The other one then branches out and goes down south. We take another one from here. This one, we take it south, looking at the wind, ensuring that the line we draw is parallel or tangential to the wind direction, to the winds, tangential at that station. The line must be drawn tangential. Then we take it there, down south, or well, down south, then turning around at this point, and I see wind here, almost like a westerly. This one has to respect it in that way, and there's another wind that is not southerly, so there's one, it has to branch out up north, while this other one, there's another wind here, so this one will branch out there, and it's forming a asymptote of divergence over here, and also over here the same thing. It goes like that, and then southwards to this point, of course respecting this direction. Here again there's a branching out on the basis of the wind direction. This one is a westerly, it goes westerly, but this one is from northeast. It turns and goes that direction and continues until it gets to this point. The wind is again from northwest here, it turns around and then eventually enters, becomes an anti-clockwise flow over here, because this wind is also suggesting that there must be an easterly, southeasterly. So this one now forms a C, which is the cyclone. And before then, we see here, this line comes here, and because of this wind, it branches out like that, asymptote of divergence. Look at this one again, branching this way. And at this end, it's also going northwards, branching out like that, and also like that. So, but over here, the winds are here, you have asymptote of divergence, and also asymptote of divergence. Over here, asymptote of convergence, and asymptote of convergence. So the wind really comes in here, comes in there, and goes out this way, and there, that way. And this is what we call the neutral point. Right? And then we come over here, we take another line here, parallel to this. So it doesn't seem very visible, but we take it here parallel, and then continue respecting this direction, and then when it comes here, we turn around respecting this direction. Another one is taken again here, down there, but that's where the map stops. And then here, the same thing, and then here we follow it this way, and then turn around because of this direction. And since it's an clockwise form, this is an anti-cyclone. That's how this has been drawn, and this one also is turned like that. Over here, we have also wind that way. There we take it also parallel. It's almost a westerly wind. It turns around because of this wind going south, northerly wind going to the south. It turns around there, and then here is almost like a westerly, easterly rather, and then turns this way. And eventually we see a clockwise flow here. That's why we have an A here, meaning an anti-cyclone. This one again goes down because of this wind, and eventually has to go up because of this wind, and then joins this as a asymptote of a convergence. So that's how this streamline analysis is carried out. The important thing here is that you draw lines that are parallel or tangential to the instantaneous wind velocity at each station. Ensure the lines are parallel and follow it that way, and then do the labeling. So at this juncture, I will bring this lecture to an end, and then the next one will be for West and North Africa. Thank you very much, and God bless.